body like this of mass m specific heat. It is having initial temperature T1. I'll supply heat. Then, so what will happen to the temperature of the body as increased to T2? This is solid. Huh? So what you're going to write Q as the heat supplied to the body or heat absorbed by the body should be equal to ms into T2 minus T1. So what is M? M will be specific heat. Sorry, S will be specific heat and M is the mass of body. Okay, fine. Similarly, let's talk about the gas. Let's talk about the gas. So this is some amount of gas. It is having mass, molecular mass, and specific heat. So it is initially at temperature T1. I'll supply heat. Then what will happen to the temperature of the gas here? So I'm interested here. So therefore, so definitely, what will be your answer? Okay, what is there, sir? Use same formula. Okay, let's try to see that how far this formula is going to help us. So it was the mass will remain same as it is. Capital M we were using, no? M naught S. So the final temperature, let it be T2. Then what is the formula here? Q equal to mass of gas into specific heat of gas. There is no doubt into change in temperature. Mass of gas, I think you know enough of chemistry. We try to express in mass of gas, very difficult quantity to express that one. So usually what we do prefer to express in terms of number of moles. So therefore, and what we know, mass of gas equal to number of moles into molecular mass. So further this will be N M naught S T2 minus T1. Number of moles as it is. So this M naught into S, I'll call it as molar heat capacity. Fine. So there's one C, like I will define it. So this will be, what is C is called as molar heat capacity. So therefore this C I can also write in differential form, dq equal to NC dt. What is N? N number of moles. See the molar capacity. We can define this as dq by N dt. And for a given gas, for different process, it will be different. Molar capacity, what is this? For a given gas, it depends on the process, not on nature of gas. Look at the water. What is the specific heat of water? 1 calorie per gram per degree Celsius. Specific heat of molar capacity of hydrogen, not a fixed quantity. It depends on process here. The molar capacity of a gas depends on the process is telling. Sir, how it is possible? Later on we'll go in depth here, that one. So time being, no. So what is a, similarly, what is a convention now? So we'll go for convention. Q will be positive when it is absorbed by gas. Q will be negative when it is rejected by gas. What all you have in chemistry, no? Better try to avoid all, forget. Just with empty mind, you just sit in physics class, it'll be very easy for you. Don't compare them, totally different things little bit. Okay, if a body absorbs heat, so we take positive, temperature of that will increase. If a body absorbs, if a body gives out heat, temperature of that decrease. So this is the conventions we are putting. So if a body absorbs heat, Q will be positive. If a body rejects heat or rejects or heat is rejected by gas. So don't say body now. Now say goodbye to solid liquid. We are going to discuss exclusively the gas. Why the priority is given for gas, that you can see later on. Okay, this is about the convention. Like this, the heat absorbed or rejected. Who will supply heat? Next question comes. How to supply heat to a gas? What is there? Just put nearby Bunsen burner frame. Okay, you take the ga gas in a container. How to supply heat? So what are the process? So I'll take the Bunsen burner. So there's a gas, no? So let this be a conductor, conducting box. So what this flame will do? It will supply heat and the gas will get, no? So there's one method. Next, another method is I will put an heater coil, dietland heater coil. Okay, let a current I flow. Heat will be generated. We know heater coil, all of you, water heater. Similarly, what will happen? If a current flows, heat will be generated, that heat will be absorbed by the gas. Okay, these are the two things. Heat will be supplied by many means are there. These are the two popular things which I'm just wanted to tell you that one. So what is this? This is a heater coil. Electric heater coil. Okay, like this we can supply or we can extract heat also. Extract it means I'll bring cold body in contact with this one. So it can, the gas or pan can exchange heat to surroundings through this one. Suppose that the temperature of gas is higher than surrounding, then the heat will definitely flow from the walls of container. So it is giving out heat. In this way, what will happen? The Q is what we are going to supply or take it from the gas, that one. Okay, no. This is okay. Next, we'll go for the work done. We'll define internal energy. Can you remember we have discussed in detail about this also in KTG? Let me save it. Let's come for. So the next one is